Okay. That's going to talk back at me. I'm sorry. You'll just have to ignore it. Okay. A blank is a three-sided polygon. What do we call it? A triangle. Yeah. That's literally what I wanted from you. A triangle.
I got it.
Okay. A triangle is a three-sided polygon. Not today, but someday. To name a triangle, and we've already named triangles. We've done this before. But to name triangles, you can just name the three letters in order. So you use the symbol of a triangle. And then how do you want to name this one?
ABC.
ABC? So I could call this triangle ABC. Somebody name it a different way. BCA.
CBA.
Whose hand did I see up over there? Hunter, do one.
Can you do different letters?
Yeah, well, you can do you've got to use these letters that are here. Ben, go for it. Cab, C-A-B. Okay? So the order of the letters for naming one triangle does not matter. Now later when we talk about congruent triangles, it's going to matter a little bit. But for today, when you're just naming a triangle, 3 letters. Okay? Okay, when we're classifying triangles, there's 2 different ways to categorize them. Does anyone know the 2 ways you can name triangles?
Yes. Yes.
Jemijah,
What?
did you have your hand up?
Yes, rotation.
Okay. Nope, we're moving on to new stuff. I see where you're coming from with that. Hunter, what's one way to classify a triangle? Like, what's one thing we care about in a triangle? Yeah, that you had your hand up. Okay, isosceles means what? Do you remember? Will? Okay, yep, that's... we're going off of 2 different things. There's 2 different things being talked about right now. Jemijah and Hunter, enough. Isosceles means there are 2 sides that are congruent. So we could name triangles by their sides, and specifically their side length. And then, Will, what was the one you just said? By the angle measures, yeah. So side length and angle measure are the 2 ways we can classify triangles. Okay? Side length, angle measure. So it's sort of like having a first name and a last name. I can give you any triangle and you can give it 2 names. One name based on its sides, one name based on its angles. Okay? So if you want to go by side length, you have the scalene triangle, the isosceles triangle, and the equilateral triangle. What's a scalene triangle mean about the sides?
Not all the sides different.
A wedge type.
Ben, go ahead and say what you said.
Not all sides and angles are the same.
Okay, and in fact, even more specific than that, none of them can be the same. Okay, so scalene triangle means no sides congruent. Okay, so we call it scalene when none of the sides are congruent. Okay, no congruent sides. What's an isosceles triangle? Go ahead, Ben.
A triangle at least has 2.
Good. And I love that you use the word at least. Okay? So an isosceles triangle has at least, sorry for my handwriting, 2 congruent sides. Why is the at least important? What do you think that means?
The lowest.
Okay, the lowest is 2. You can't have less than 2, but you could have more than 2. So you could have all 3 be congruent. Okay? So let's go in this picture right here. I want you to mark these 2 sides as being congruent. Okay? And then what's an equilateral triangle? All the sides are the same. Yep. So all sides congruent. So in this triangle, we're going to mark all three. So an equilateral triangle has all of the sides congruent. Does that mean that that's also isosceles?
Yeah, because it said it's the least is 2 and it can.
That's right. So if it's equilateral, it has all three congruent. Does that mean it has at least 2?
Yeah.
Yeah. So every equilateral triangle is a type of isosceles triangle. Okay, every equilateral is a type of isosceles triangle. That's important. Okay? So that's when I ask you for side length, classifying by side length, these are the words you're looking for. Okay? Scalene, isosceles, equilateral. Let's talk about angle measure. Okay? What's an acute angle? Close, Darian? Less than 90, okay? An acute triangle has to have all three angles be acute angles. All three angles. Just a second. All three angles are acute. Okay? All three angles are acute. What's a right angle? Darian, go ahead.
It adds up to 90 degrees.
Not adds up, just
I mean, it is 90.
it is 90 degrees. Okay, so a right triangle has to have one right angle. Now, why is it that an acute triangle has to have all three angles be acute, but a right triangle only has to have one right angle?
Because that's equal 90 degrees.
Okay.
Wait a minute, what was it?
Why doesn't a right triangle have to have 3 right angles?
Because it can't.
Because then it would be a box
Why
square.
couldn't it? Okay, good. If I were to draw something with 3 sides that had 3 right angles, I would have something like this. I would have a right angle here, and a right angle here, and a right angle here. Okay? And you end up with a box, a rectangle. Okay? Or, if I wanted to make sure that I still only had 3 sides, it would be something like this. One side, and then the other one would be over here. Okay? Oh, I guess that still doesn't even have 3 sides.
Wouldn't that be like an open ticket?
Yeah, right. But to have 3 right angles, you're going to end up with something that looks like that. Okay? So a triangle can't have more than one 90-degree angle. It couldn't even have 2 90-degree angles, because 2 90-degree angles would look like this. Okay? Mathematically, why can't a triangle have 2 90-degree angles? Any thoughts? Okay, what do the angles in a triangle have to add up to? Okay, the angles in a triangle always have to add up to 180. If you have 2 90-degree angles, you've got 180 degrees right there, and you don't have anything left for that third angle. What's that? Well, what I'm saying is if you had 2 90s, there's your 180 degrees right there. You wouldn't have room for a third angle, which is exactly what we're seeing right here. Okay? So a right triangle is only going to have one right angle, and the other 2 angles are going to be acute angles. Okay? So when you say that something is an acute triangle, you can't just look for one acute angle. Copy, put that marking in. You don't have to draw my sketches, but mark your triangle. Okay? If you were to look at this triangle and say, oh, look, there's an acute angle. This must be an acute triangle, isn't it? If you were to look here and say this has an acute angle, so it must be an acute triangle, you'd be wrong. To be an acute triangle, you have to have all 3 angles be congruent. Okay?
I just said that.
Glad I've entertained you today.
Yes.
Okay. Okay, good. I'm glad you like it. It works better in some lessons than others. If there's a lot of writing, it's hard for me to write fast enough for you to keep up with it. So, but I'll try to do it more often. I sure can. Okay, so an obtuse triangle. Could I have more than one obtuse angle in a triangle?
No. Yes, you can. It can equal
What's an obtuse angle? Let's start with
Less
that.
than 180.
More than 90 is an obtuse angle. So it would be something wide like this.
95.
And then if I had something else that was obtuse, it would go out like that. Can I make a triangle like that? No. So again, this would only have one obtuse angle. Obtuse angles are less than 180, but they also have to be more than 90. That's the more important defining factor. Okay? Good with those words? So again, that's if I tell you to classify by angles. Okay, classifying by angles. So when you're doing your homework tonight, it's going to be very important that you read the directions. Okay, because sometimes I'll ask you to classify by sides, and I'll get people saying acute. Acute is not talking about sides, it's talking about angles. Okay? Okay. Ben.
Can I say?
Sure.
Yeah, oh, I wanted to say it.
I'm sorry, dear. Go ahead.
Triangles
Equiangular.
equiangular if all sides and angles are the same.
Okay, technically, equiangular, what word do you hear in there?
Equal.
Equal and angle. Okay, so equiangular technically means all angles are congruent. But I'm going to come back to the other thing you said in just a second. Okay, equiangular means all angles are equal or all angles are congruent. Okay, so it's going to look something like this. That, and that are all equal. But in a triangle, if all the angles are equal, what do you know about the sides?
Equal.
All the sides are equal too. Okay, so write this down someplace. Let's do something else.
Do pink.
Pink's hard to read. Equal angles is the same thing as having equal sides, and vice versa. Okay. It's also easier if I set the iPad down, but that's hard to do when I'm sitting here. So, if you have all the angles equal, then you also know you have all the sides equal. And if you know all the sides are equal, you know all the angles are equal. Okay, that's a theorem we're going to learn later, but I want you to know it now. Okay, that if the angles are all equal, then the sides are equal. What's the word we use when all the sides are equal?
Congruent.
Okay, the sides are congruent, but what do we call the triangle if all three sides are equal? Ben? Equilateral. Yep. So equiangular is sort of the same thing. I don't want to say the same thing because the words mean different things. But any triangle that is equiangular is also equilateral. And I'm going to have a hard time fitting this in. Oh, I have a trick for this. How do you like that?
Boy,
Zoom.
Okay.
Oh my gosh.
that is
Every iPad is
unbelievable.
Zoom.
But I want you to know that equilateral, and now I'm not spelling equilateral right.
Oh my gosh.
Okay? I want you to know equilateral and equiangular are sort of the same thing. Okay, in a triangle. That if you have it equiangular, it's also equilateral. If you have it equilateral, it's also equiangular. Okay? This I already knew how to do. I just hadn't done it with your class yet. But okay. So this says classify triangle EFH. I'm sorry, EHF, but same thing. Be careful in a picture like this because do you see that there's more than one triangle in that picture?
Yeah.
Pay attention to what triangle it's talking about. If it's calling it triangle EHF, you want to trace from E to H to F. E to H to F. Okay. What do you notice about those side lengths? Okay, it's a triangle, yes. The sides, though. And this is what I'm talking about. Be careful about directions. I said side lengths. Okay? I see a 12, and then I see a couple of little lines. What do those little lines mean? Nope, I don't care about right angle. Congruent. The sides are congruent, right? So, Hunter, what are we going to call this one?
Isosceles.
Isosceles, yeah. It's got two congruent sides. has a congruent side here and a congruent side here. Okay, so we would call this an isosceles triangle.
Capitalize the R.
Okay, that's isosceles. Then it says classify triangle FHG by its side lengths. Let's see if I can, oh, I can't get rid of that. No, I want to get rid of that. There we go. Okay, so now I want to do triangle FHG by its side lengths. Well, here I see a 4 and 11. How long is this side? 10, because it's equal to this one, right? Okay, so 4, 11, 10. Do I have any congruent sides? Nope. What do I call it if it has no congruent sides? Good. Scalene. Good, good, good. Okay. Then it says, what is the length of FH? Oh, I already asked you that question. We're ahead of the game. What is the length of FH? 10, because it has to be equal to that 10 down there, right? What is the length of EG?
14.
14, good. You've got to go that whole distance. Good. So 10 and 4 make 14. I didn't give you any examples where you had to do angle measures, but I think you'll live. Okay, so big important thing for today is those slides with the vocabulary. Okay, the slides where it tells you what scalene and isosceles and equilateral mean, and then the slide where it tells you what acute and right and obtuse mean. And then read directions in your homework. Is it asking you for side lengths or angle measures? Sometimes it's asking you for both. Actually, let's do one more example real quick. Okay? Just follow along with me here. If I give you
Circle.
we're talking about triangles. How would you classify that by sides? By sides. Look at your sides words. Hunter?
Equilateral.
Okay, it's equilateral. Good. What else could I call it? By sides. What other word is true? Isosceles. Because it has at least two sides that are congruent. Now, which one of these words is more specific? Equilateral is more specific. So if it just asked you for one answer, this is what I would go with. But if it said name it in all the ways that you can, I would also call it isosceles. Now, what about if I asked you to name it by angles? What if I asked you to name it by angles? What would you call it? Will? Acute. Yep. All of the angles are acute. Does it have a right angle marked in it? No. Okay. There's one other word we could use. Darian? Does it have an obtuse angle in it? No. There's one other word I taught you about angles. Ben? Equiangular. Good. Okay, so we could also call it equiangular. Okay? Let's try. Let's do...
Whose phone is that?
How would you name this one? By sides and by angles. It's right, and that's angles, right?
Yeah.
How about by sides? Isosceles, good. Okay. Let's call it good.